By my clock, it's time to begin, so we will. This is the second session of the LAMPS working group this week. The note well still applies, so please make sure you are aware of your rights and your privileges, and most importantly, your responsibilities to participate. Please don't participate if you aren't going to follow this. Please treat each other well. Keep, it's okay to disagree with somebody, as I'm pretty sure we'll see in a little bit. But please do so respectfully. We have a 7-page agenda. So we are now at this point in the meeting on part 5, where we're talking about the composite signatures and the composite chems. They were combined into one presentation. We will resume that one. But are there any other agenda bashes? Okay, so let's get to it with jumping in where we were. Sure. I know we saw.
Hello again, everybody.
Composite signatures and
work?
chems.
Were we able to reconstruct the light cube from last time?
Ha!
No. No. All opinions are useful. Let's not lose any.
You have to plug that in first.
All right. I
Thank you for hitting the back.
think we were here.
Yes. Oh, you're doing it. Yeah. Okay.
We were on slide 7, right?
Yes.
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 No.
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 We're on slide 6. We had only gone through
Okay.
the peer mode. So again, we pass in the context. Step 2. That's where we do the message format. Oh, is the mic not on? Oh, okay. Is that? Yeah, that's better.
Eat it.
Okay, you
There
can hear
go.
me. Great. Yeah, so just to recap, yeah, we pass in the context. Well, at the high level, there's a context that can be passed in that's used at the application level on step 2 to do the message format. Then we use a different context on step 4. So that's used for the MLDSA context, and that passes in the domain. So that was where we were when we left off. And just before we were going to go into the next section on the hash, there was lots of questions. So I don't know if people remember what their questions were, or we could just go on. So if I don't see anyone, so this was the next, so we support peer mode. So this is the pre-hash mode. The difference is now we allow context to be passed in. Again, this is an application level context. And then there's the pre-hash. So again, this aligns with FIPS 204, section 5.4, as mentioned there. Step 2 is a little bit different. Again, we take the length of the context. Now we take the hashoid. So that's, again, that aligns with what they do in FIPS. And also and then using that hashoid so that the actual algorithm that represents, hash that with the message.
Okay, you have someone in line.
Can I
Yeah, go.
take author's? Before Falco, I'll take author's privilege here. So we've had some good discussion this week that we don't like section 5.4 of FIPS 204, and we'd like to pretend it doesn't exist, in which case mirroring it is a bit of a bizarre choice, but we wrote these slides before all of these lovely discussions. So if LAMPS wants this to just disappear, that can be done.
Okay, I guess Falco.
Yeah, I have a Falco MDG. I have a comment regarding the buildup of M prime. So I'd propose to prepend a longer constant string in the front, because if signature stripping happens for the traditional scheme, there is no protection due to lack of context, so there's no domain separation. So there will be a valid signature for M prime if the PQ part is stripped out, the PQ signature. So that means if an application wants to detect signature stripping, it would have to check the format of the message. And in the current proposal, this cannot be done because the only constant leading constant part is the byte 06 as the first byte of the OID.
Okay, so you're suggesting the domain, we make it longer.
No.
Oh,
No,
okay.
to prepend a constant part of some magic bytes of whatever length,
Okay.
maybe 10, 20 bytes. So a hardened application can check for this sequence, which will, with overwhelming probability, not occur in an actual message of whatever kind. So it could just say, this is an attack.
So for example, we could make domain the ASCII bytes of the word composite and then the OID, and that would accomplish your goal.
A bit too short for my taste, but from the idea, yeah.
Sorry, how long would you like it? Because we can make it as long as you think is needed.
I would suggest 16 or 32 bytes, maybe. But that's maybe subject to discussion.
Okay, great.
But it should be cryptographically, it should be something like comparable to cryptographic security that we are aiming at.
Falco, since you're at a computer and I am currently not, would you mind putting that as an issue on the GitHub?
I can do so, yeah.
Deirdre at Sandbox, agreed with what Mike just said about not necessarily matching the hash composite sign API signature with section 5.4 of FIPS 204. Include the domain and other stuff inside, but do not include a context parameter in the signature API. If a protocol,
Like this one, you were talking about this one, right?
You want this slide to stop existing.
kinda.
And then you have a
Kind
comment
of.
on- you have a comment on the previous slide.
No.
No.
Yeah. Anyway, don't include context in this external signature. Maybe you are using it when you call MLDSA internally, whatever, but do not necessarily expose it as part of this external API. If a application wants to do something similar, they prepend their application specific context to the message that is passed in there. That's what we do now.
That's what we do now.
That's what we do now.
What we do now is a
Okay.
really bad reason to not do better in the future. That was DKG's argument last
Go
time.
way
Yeah.
closer.
So can you go back one slide, John, to the not PH version? Okay. Section algorithm 2 from 5.2, I think, is fairly non-contentious that, this exists. I think any argument that we should not mirror the external API of this, like the obvious thing is this is what FIPS 204 does, will expose the same API. I think any other argument is a tough argument to make. And DKG, I think quite eloquently last time said, we don't do it today is a bad reason not to improve security in the future.
Okay, you need to go to the microphone.
I'm skipping the queue slightly, but to say that.
Okay.
So, yeah, so this extra domain separator there, it probably isn't contributing anything to the non-separability because you're already getting that in the OID that comes before. So
I think that comment is more appropriate for NIST than for this draft.
No, it's, I disagree. It goes to both because if we're going to do this or not is the question.
So Britta, you're saying the first step where we pass in the context, not to pass the context there because it doesn't add any security.
So I'm not weighing in on whether or not pass the context there, but I am saying that it's not adding any additional.
It's not adding additional security. Okay, yeah. So the reason we added that, well, again, for the alignment, but also if an application wanted to, use it to bind specific to their application use. So you're saying that doesn't help.
I'm not weighing in on that part, only
Okay.
on the non-separability guarantees. And
Okay, okay.
Okay, Bert, you're up.
Do you mind if I go?
Thanks. Bert Kliski, VeriSign. So appreciate the work in this area. I did put some notes on the list and wanted to confirm I do support the design as it's set up now, modulo the comments here. I see that keeping the context in the API is good for extensibility. Context doesn't have to be used when it's called, but the important part is the context in the lower half of the slide, where a context parameter is passed into the MLDSA or SLHDSA if you were using that in another construction. That separates different uses of the key at the lower level. So I'm supportive of the general direction on that. We'd like to see the flexibility.
Daniel?
So can I respond to Britta before we take the
Oh,
next?
sure.
And Deirdre, so my concern here is not a cryptographic concern about context. My concern is an interoperability concern. If we have things that implement against FIPS 204 and then use the context for good or bad reasons, but regardless, they use it. And now you give them an X509 certificate and we don't allow them to use it. And they're like, but my protocol uses it, so I can't use my protocol with X509 certs. Like, this is going to be just weird.
Daniel?
Okay, so I guess regarding the context, see Falco and Mai's later presentation about potential use case for that. If it doesn't actually add security, then obviously we might not want to do it, but I think Falco will have reasons why it will. And regarding the pre-hash APIs at the higher level, for MLDSA, we were able to kind of ignore the pre-hash APIs because we can do the message representation separation, but we can't do that here, I believe. In a easy interoperable, not interoperable way, a clean way, I guess is the question. I know you can pull it out, but now you're kind of messing up the hash or the composite MLDSA sign by having to pass in a message and also message for ECDSA and the message representation for MLDSA.
To shortcut this, I'm going to make a proposal to all the Doctor Who fans. Imagine this slide is empty and contains what you want it to contain, and in 2 months we can debate whether what we put there matches what you think should be there, but maybe we punt this.
Okay.
Sophie?
Okay, so first to the domain separator, note that there is now in the draft, thankfully, a line that says that you're not allowed to have keys used separately. They need to be generated together. They need to live together, die together, which makes the domain separation a lot less necessary. I do think that, like, I mean, domain separation is great. We should just always put as much as we want there. So I'm not opposed to doing that. But someone doing a signature stripping is in any case a problem. And I don't think that having even like cryptographically many random bytes in front will help you against domain stripping or signature stripping in all cases, because there's enough protocols where you can just ignore the first X bytes and still have a valid message. So like there isn't enough that you can put there to always be okay. So I think the main defense against signature stripping, in my mind at least, is the fact that you must not use the keys individually. And then the domain separation is a nice, like, making it more robust, but like I don't really care how much we put there. For the context, I don't know. The weird thing with the context is that this kind of shows what the problem is with the context in the lower layer, in that it's a bit, so the context is supposed to work like the associated data in an AED. In an AED, you desperately need that AD because you otherwise don't have a way of authenticating a message without also encrypting it. Here, we don't have that situation because we have a way of authenticating a message because that's what a signature scheme does. There is like one thing that would make this a lot less cumbersome to deal with. That like I don't know if we even should start doing this, but AES SIV CMAC, so not AES GCM SIV, but AES SIV CMAC has explicitly, like it's an AAD, and it has explicitly the ability to support infinitely many contexts, infinitely many ADs. And if we had that, we could do this much easier, because we would just take one of the context for ourselves and expose the rest of the infinitely many context up to the caller. But without that, we get to this point where like, yeah, we use the context, but like now the context is not really the same as MLDSA does in some ways, but it's also the same construction. So I don't know. I don't know if it's like, I'm also not convinced that it helps with signatures, because this problem here, I'm sorry, I'm talking a lot. This problem here also happens whenever you have a library that uses a public key and creates a signature and then exposes that up for the higher level. You still get that problem of like having to add the context and expose it to the higher level. You can always do this construction though, so maybe it's not a problem. I don't know. It's a weird thing to have to worry about. If it wasn't there, I would be happier, but if it's there, then maybe using it is the right thing to do.
I believe you have surpassed some sort of complexity limit for how much information I can absorb. Can you write some of this down, please? So, yeah, I think most of what you said would be easier in written form. Second thing, and maybe to shortcut some of this microphone stuff, we the authors, with help from Dr. Hale, with help from Falco, have spent a lot of effort in the last month on the security consideration section that addresses all of this. So I would please ask everyone to take a very careful read of the newly written security consideration section. And if you disagree with the wording of the security consideration section, I would love to see that on list.
Scott, this is Scott Fleur, Cisco Systems. I agree with Bert that the outer context that's online, that's an input to the hash composite makes a lot of sense. If you don't use it, it basically just adds a 0 byte to the message. No, it's not a big deal. In addition, I would disagree that it does not add security. One security is like an AAD for an for say ASGCM, because it also allows you to distinguish between two valid encryptions and which one is meant for which context. So that you.
Thanks, Scott. Scott is one of our co-authors on this draft as well. So.
Daniel Van Gies, CryptoNext. Sophie is right that this document says you shouldn't be using a private key outside of the context of the composite. However, we've already seen in IPsec.me an attempt to do this. To do exactly this. I think at least they're within IETF, so we can talk them out of it. I'm aware of other people who want to do this outside of IETF. I can only disagree with them for so long. So, so at least as a kind of defense in depth, belt and suspenders kind of thing, it seems prudent to keep the context passed into the MLDSA sign.
Bas Westerman, Cloudflare. I think there are two questions here. And the first question is, do we support a context in composite MLDSA with whatever? And the second question is, do we use it in signing CRLs, whatever? I think supporting it makes total sense, because it's nice to switch between FIPS 204 and composite, right? That makes total sense. Whether we use it for signing CRLs, that's another question, and I think we don't need to answer it here at the moment.
Yeah, correct. And I think that's right. So you're actually the author of dilithium certificates, which can say when the thing you are signing is a certificate, there is no context. And similarly, there's a CMS MLDSA draft that says when the thing you're signing is CMS, there is no context. Those are protocols that LAMPS owns. The question is, people use certs for protocols LAMPS doesn't own, and if they want to do this, should we block them? Yeah.
Yeah, and obviously you know where I am too. Having the context there, like Bert and Scott said, it gives applications the ability to use it if they need it. If they don't, we get that extra 0 in there. Not a big deal. So can we move on now? Are we actually
Your
gonna?
queue's empty.
Okay, great. Okay, so now we're going to talk about ML Chem. So Mike's going to talk about it.
Let's do the next one. This one will be non-contentious also. Okay, this slide looks a lot like the other one, but it's a chem. We have not made any substantial changes. I want to point out that this is now, for almost all intents and purposes, identical to X-Wing with some footnotes. Yeah, with some footnotes. We've had one meeting so far with NIST about this. We haven't seen SP 800-227 yet. But we asked NIST if this looks like it's the thing that they want, and it sounds like this is mostly good. Domain at the end is an important thing, so that's good. There is a slight hiccup about order. Do I want to get into that in full? I am not going to get into that in full. So I think this is aligned. My point here is this orange yellow thing is aligned with NIST. It's aligned with other working groups. It's aligned with X-Wing. I think we're done hammering this thing, I hope. I do want to point out KDF here. This is a choice that LAMPS has made that is slightly different from other groups. For KDF, we allow either HKDF SHA-256 or SHA-3-256. So that's down. That's fewer combinations than before. Someone pointed out to us that ML Chem at all security levels only ever returns a 256-bit output. Therefore, we only ever need to output a 256-bit output, which means that we can squish down the number of hash functions combinations. And I'll return to this point when we get to the massive table. I'll make a follow-up point on this. So any comments on the construction?
Shocking.
The combinations list. Okay, signatures.
Yeah, I was gonna say. So there's 14 combinations of pure, and there's 14 combinations of pre-hash. We don't like the fact that there's so many. If we wanted to decide whether we would just do pre-hash, I guess, or pure, that would greatly reduce the list. We actually had to add a couple more because we had one on the list, Swift, you've probably seen that. They asked for RSA 4096 combination, so we added that. So no, so this, we're doing signatures and chem. So the first two slides here are the signatures, the OIDs for the signatures.
This particular slide is
This slide is signatures, MLDSA, composite MLDSA pure. The second one's MLDSA pre-hash. And if I show you the third one, that switches back to chem. But I just thought we were going to talk about the signatures first. Comments.
So given the discussion this week that we want to pretend that FIPS 204 section 5.4 doesn't exist. We want to ignore that pre-hash exists. Depending on how we rework that slide that I said, imagine it's empty and contains what you want it to contain, we may be able to delete these 14 also. Because I mean, if we do it the sort of implied pre-hashed mode thing, then it's one public key, one signature algorithm, one OID. You don't need the bifurcation. So we may be able to go from, we went from 14 to 28, we may be able to go back to 14.
However, if we don't have a pre-hash, then things like signing large CRLs, you wouldn't be able to do that. But obviously, there was a decision made about MLDSA, I think, yesterday that wasn't going to be done. But
That's right.
so, I mean, if the same decision is going to apply to this, then we would get rid of this list. So please give us feedback on that. I'm not sure that's an easy thing to decide because it does have implications in lots of use cases. So, but if there's a way that we can get the list smaller, we want to do that. So now we're going to go to
Wait a
chems.
minute.
Oh,
I want
Russ wants to say something.
Clarification question on the two previous slides.
Yeah.
When you said only use a given key pair with one composite, is that one composite and it's pre-hash, or is that one composite?
So the OID represents, like, so if you're using the pre-hash OID, then you're using the pre-hash construction.
So you already can't do what you just said.
Let us work out the details of that before we
Okay.
answer questions on it.
I think we
You're
can, but,
asking detailed questions about a construction that we haven't written down yet.
okay, go ahead.
Bas Esteban Cloudflare, so if we ignore the slide and go to the pure one, right? So this it's a long list, but if you look at, for instance, the one where we combine MLDSA.
Which line
They're
number?
Numbered.
Which line number? We added the line numbers for you.
I'm now looking at the last comment, but I have to skip over. Let me see. For instance, 12. Right?
Okay, 12. Yeah.
Say 12. It's not my favorite one, but I mean, it's one with ECDSA and MLDSA. Well, MLDSA, we can compute this into modules with the trick the true MLDSA prehash, we jokingly called it, where you compute the mu in one module and then finish it up in another module. Right? We can do this for MLDSA. Also with the ECDSA, that's one where you can also hash it separately, right? So that one can be, there's no CRL signing problem there, right?
Yeah.
There is a problem with ED25519, so maybe we have to think a bit more about that one. But there's another question. Is there anyone in this room that wants a hybrid today with MLDSA and ED25519? Maybe you don't need it in the list now, at least in the initial one. So.
Okay, two thoughts. So you're suggesting that line 11 can just be deleted and no one will notice?
Well, I say, I don't say we never have it. I'm saying if no one in this room wants it now, then maybe we don't have it in the first version.
Can you say that on list, please? So there's a written. And then second, I'm going to answer your first question now, which is we had a comment on our GitHub specifically to line 12, specifically to line 12. We had a comment of someone who says that their hardware exposes a ECDSA with SHA P384, sorry, ECDSA with SEC P384, SHA 384 as a single hardware API. Atomic operation, please don't separate them. I don't know if that was exactly your question, but correct.
Yeah. My comment is mostly for this list. Can we make it so that entries only get added to the list when someone explicitly asks for them, and sort of start with an empty list and only have an entry when someone asks for it? For example, I don't know if anybody uses ED448. I have not seen ED448 in practice anywhere. So I would just not have it there until someone says they need it. And if they need it, sure, throw it in there, like.
Okay.
11 and 14.
So, and probably, yeah, probably also the one, there's probably 3 as well, number 3 as well.
Several ones that like nobody
3, 11, and 14
has requested, and let them request it at least.
Okay.
Would be my idea. Like, let's not like preemptively add stuff that nobody wanted.
Yeah, and that's why the brain pools are there, because originally they weren't, and then they got requested. So 3, 11, and 14 are candidates
And
for
1 and 2.
removing. Oh, and 1 and 2.
1 and 2 may be in that camp also.
Could be 1 and 2 as well. Okay, thank you. That's a great comment. Okay, back to chems.
No, you got 2 more people.
Oh, sorry. Oh yeah, sorry, John.
Thank you. We use ED448.
Well, never mind. Okay, we'll add them back then.
Ericsson is planning to use as much ED as possible in the PQC transition. So we would like all ED, as much ED as possible, and everything else can go.
Okay. So we'll amend our amendment and put them back then. Okay. So ED448 though. What about the the other one, 25519? We'll take it to the list. Yeah, it's still ED, yes. Okay, we'll take it to the list.
Pause. Okay. No,
Okay.
well, okay, he's done.
Okay, so this is the chems list.
Okay, chems list. This is the chems list.
It's smaller.
It's smaller. Actually, it's smaller thanks to Sophie having made a comment similar to the one she just made, but one IETF ago, and told us to remove the level 1s. So that's why it's smaller. Yay. yeah, this does not have MLChem 512. Thank you, Sophie, for giving us a concrete thing we could delete. So far, no one has complained, so this algorithm is working. The observation I want to make.
Someone didn't jump in the queue, right?
That's how this works. Okay, so the observation I want to make deals with the last column. So we have heard feedback specifically from Deb and specifically from Joe. Hi, Joe. That we may not have SHA-3 available at the layer of our application that needs to do this combining. Yes, SHA-3 exists inside MLChem, but we may not have easy access to it, and therefore we need SHA-2 based combiners. Cool. We can do SHA-3 naked with nothing. We cannot do SHA-2 naked with nothing. We need to wrap it in HKDF. So you'll notice that we did not double the size of the list by offering every option with both SHA-2 and SHA-3. Instead, we made an opinionated choice to say the lower security things use SHA-2 and the higher security things use SHA-3. That is observation number 1. Observation number 2, it has come to our attention somewhat recently, thank you to Panos, that HKDF is not FIPS approved.
Yes.
HKDF, from our conversation with NIST, HKDF extract is FIPS approved because it is literally just HMAC, but HKDF expand is not. So I think this list as it is presented right now is not FIPS compliant, but we're gonna, I think the way, I have a slide later on, I think the way we're gonna do that is just say what we mean by HKDF SHA-2 is just the extract phase. Okay, Q.
Yeah, Deirdre with Sandbox. I was just looking at the version in GitHub, and I think the MLChem X25519L line 4 is still using HKDF, not SHA-3 yet, but we can double check that. I kind of agree with using HKDF SHA-56 where you can. There does seem like we could write down the thing that, like, if you squint at it and you very carefully say we are using HKDF extract with SHA-56 in these places where you're doing key establishment or whatever the line is in the, you know, FIPS document that says you can use it in this scenario, you can basically say this is fine. There's also plenty of signals that NIST is basically trying to move towards saying HKDF with SHA-56 is fully a KDF. We're not there yet, but we've gotten some signals that they're interested in that, and that would be very lovely if they did do that.
I have many thoughts on that. So one is I don't want to wait for it.
Sure.
And 2 is I'm not sure I've heard that signal. I mean, so I can tell you off the top of my head, the HKDF extract is allowed because of 56C R2 section 4 option 2, which allows HMAC.
Yes.
Done.
Yes.
You memorized that.
I've been in this document.
Yes. And the last point is if you did change away from using SHA-3 for the 25519 combiner, you would have the LAMPS X25519 MLChem 768 combiner that is its own thing, that is fully FIPS compliant, that is different than X-Wing, which for other reasons is slightly less FIPS compliant because of the way we define how you generate seeds. Because we generate a 32-byte seed, expand it with shake, and they are not allowed to do that in FIPS at the moment.
I think I have a slide on that you'll want to come back up for when we get there. Yeah, so I think sort of the summary there is, do we want option 4 to be X-Wing, or do we want X-Wing registered in a separate document and different from line 4? That is a valuable discussion to have. Right now, we've attempted to make it be X-Wing, and that may or may not be the right approach. Is the queue empty? Is the queue empty?
No.
No, either. So I'm not sure about the KDF because for CNSA, even like in the 1.0 version, they were asking for SHA-384 at least, and now they've added SHA-512. So for this kind of use case, we may actually need something stronger, despite the shared secret being 32 byte.
So the other design option here is we could do shake 128 to output 256 bit, which is a little more in line with the MLChem internal structure, I believe, but then it's really not X-Wing. There's constraints all over the place here. I don't know what the right answer is. Does
Sophie?
maybe does NIST have an opinion on whether SHA-3 256 is a thing you're happy with as a combiner here?
So I looked at the NIST KDF thing. I'm actually not 100% certain that HKDF extract is FIPS because it switches where the key material and the salt goes. So I would double check that.
Panos was quite confident that it was,
If NIST
but
said something else, then I am very, very happy about that because the whole
if Sophie's right, I'm very sad.
The whole thing's a mess. that part we all agree on. John?
I would like, I think Shake 256 everywhere would, or KMAC would be great. That's what I would like to see. Comment on X-Wing. I personally don't care if it's exactly X-Wing or anything else, but please don't. To like something that's close to X-Wing and something that's X-Wing sounds like a bad idea to have two things.
Just don't do two things. When?
Quinn Dang at NIST. Yeah, I just got a question, so I would like to explain further in 56C. So the HMAC KDF in 56C for one step, the key is a salt. So that salt default to be or 0, or it can be any constant. And then so that means whatever the extract step in HKDF is compliant with that. But there is one issue. No issue for you because the thing is that the key coming out from the extract step is a fixed length.
But it's this length. It's the length I want.
So let me explain. It's length. So that means in an application, if you do want to derive more keys from that, then you have to use a NIST approved KDF to derive keys from that. So that basically, beside that, you need another KDF NIST compliance in order to do everything that you need to do.
I am trying to make this look like ML, like your
Understand. I'm
MLChem,
trying to help
and
you
then
guys
whatever you
here.
do after, you do in the same way in both places, and that's not my problem.
I'm not saying the thing is you write down HKDF in there. We have your next step is expansion. It's not NIST compliance. That's what I'm saying. So even if you got the extraction and the key agreements compliance, but your next step is not compliant, then you could be a problem still.
No, this will output 256 bit. It will only ever output 256 bit. If your application wants to take that and expand it, that is your problem.
That is fine. And one more thing you just mentioned about the Shake 128 or Shake 256. Right now, the KDF based on Shakes are not generally NIST approved KDFs. We have specified either KeyMac or SHA-3s or SHA-2, or you use the constructions in 108. But if there is a wide adopted or used KDF based on a Shake, either 128 or 256, then we would likely, make decision to review it, and then whether or not we make a decision to approve it from NIST side later. But just
Scott's not at the microphone, so I'm going to keep talking.
SHA-3 there's all good according to 56C if you follow one of the options in 56C.
Okay, so we have SHA-3 is good already. We have Shake probably allegedly not good already. I'm going to, since I have the microphone, I'm going to delegate. John Matson, can you please fire something onto the mailing list that sort of describes this thing, and then we can take this to the list and we can give Lamps some minutes back. Acceptable? Ooh, next slide. Oh yeah, other stuff. This we're going to talk about basically not at all. We've simplified the private key structure. It's no longer embedding a whole one asymmetric key. It's now embedding closer to nothing. Not quite exactly nothing. There's still a sequence there, but it's closer to nothing. We've done this for both versions. Was there anything else on that slide that mattered? Yeah, this was a holdover from generic we always meant to remove, but we hadn't got to it yet. Yeah, open question. How exactly do we carry these ML keys? Are they seeds? Are they expanded? I think this is being addressed in the. When we wrote the slides, you hadn't published a data tracker yet, the dilithium certs. So we were working off some weird what was on data tracker didn't match what was on your GitHub. And so this question I think has been resolved since. Yeah, X-Wing team points out that ML and ed keys can both be generated on the fly from a single seed. Is that advantageous here? That is like the core difference between this is the keygen is different. And not the combiner, but the keygen is different between ours and X-Wing. And do we want to align that, or do we want to explicitly not align that and give them different OIDs? I don't care.
Quinn Dang at NIST again. We have been discussing the option of allowing the DNZ, which is the seed for MLChem, to be derived from a pseudo-random string. We've been talking about it, but we have not made a decision on it. So right now it's not allowed, but we are talking about it. So the best I can do is when I come back, I request my team to talk more about it, and then hopefully I can get some decision.
So I think that was exactly Deirdre's point, right? That if we want this to be both fast, like published in the next couple months, and FIPS compliant, then we need to do the black box thing where we do keygen A and keygen B. And X-Wing wants to do something that's cryptographically stronger, but isn't going to be FIPS compliant soon, which is the argument for X-Wing is not this, and they should have different OIDs.
Yep.
Okay, come to PQIP.
This was just, was there another comment? I'll just say this quick. We had interoperable implementations done at our hackathon, yay. So Dash 03, even though it was only done 2 weeks ago, published 2 weeks ago, we already had Bouncy Castle and 7th Sense AI implement it, and it all worked. So there, yay. One more slide done. Go ahead, boss.
Bas Esteban, Cloudflare. Well, with if you combine XUV 519 and MLChem 768, I really hope that someone says, yeah, next month we'll have a MLChem 768, a cryptographic module with MLChem 768 validated. That would be great news. Please tell me. But that's probably going to take more than a year. So any combination of MLChem 768 and XUV 519 will not be FIPS anytime soon anyway. So we can wait for the seed expansion to be approved. But that doesn't help if we are inconsistent in how we do the private keys, right? Between the different ones. Anyway, just wants to mention that.
Yeah. Let's talk.
Yeah, and there's another thing when we mentioned CNSA2, because with CNSA2, because they don't like SHA-256, right? But they don't like hybrids to begin with.
Scott, microphone. Scott,
microphone.
Bas just brought up Scott Fleur Cisco Systems. Bas brought up CNSA 2.0. CNSA 2.0 is very adamant that they don't need no sticking hybrid, MLChem, MLDSA only. That's it.
That's right.
Cool. Yeah. I don't care. Love it.
Okay. Queue empty.
They don't care that you don't.
So I talked about that. We're trying to get through. Oh yeah. So open questions. So Mike, talk about the private
fire.
key format. Yes.
Yeah. Okay. This is on fire. I'm gonna get roasted for this. Here we go. So seeds versus fulls. My big concern is that some hardware manufacturer, so seeds are great, like seeds are good. We want seeds for sure as the default. Everyone should do that mode. My fear is some hardware manufacturer is going to only know about FIPS 204 and not know about any other document in the world, and definitely have never heard of IETF. And they're going to go and implement FIPS 204 exactly as written, and we're going to get a fully expanded seed, and they're going for a fully expanded private key. they're going to do their keygen, they're going to throw out the seed and not have it anymore. And then the company that made it is going to go bankrupt, and Entrust is going to get hired to migrate keys to new hardware, and we're going to get a expanded seed exported, and then we can't have any standardized way to transport it because LAMPS decided we don't want to deal with seeds. This is my horror scenario, that in 10 years, we're going to have super important billions of dollars rest on this key that we cannot export. So this is horrible. I hate this choice thing, but the way we've done it, if you want to pretend that fulls don't exist, it's untagged. The seed is untagged. You can just go la 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 and pretend that only line 2 exists, and that's compatible with this choice structure. I hate.
Sean.
Go.
I'll go first, and you get rid of them. All right. So choice 3 kind of reminds me of this elliptic curve stuff we used to have with the private key format, and it was crazy pants. We should just say no. If we want to, the easiest way to do this is just not use the constraints and just use option 1. We say nothing. Constraints are optional. It's nice to have if you can really lock it down. But if you don't have to,
no, you mean option 2.
Option 2, yeah. Sorry, in option 2 of the constraints, you don't need the size constraint. You can just drop it. So that leaves you with 1. We say what we want. If they want to do something else, this is all for like. I think you could figure it out.
So Sean, sorry, which one are you?
I'm going for 1. Like
You're going
just
for 1.
I mean.
You don't want the full key.
No, you don't want 1.
You want the
full
seed,
key?
right?
Oh,
You want
sorry.
2.
It's 2 without size.
I was gonna say.
It's 2 without size.
By
I'm
the
sorry, I
way,
didn't read
this
the
is-
full.
And by the way, this slide's a bit rude because it's in the composite deck, but it actually applies to the dilithium certs draft, which you're an author of. So actually, Sean, you get to solve this.
Yeah, sorry, I was gonna just draw in there too. Another reason the choice idea came up, because I've heard there's also another longer key format. So there's more than one, apparently, for optimizations, maybe in hardware and things. So again, the same problem. If there's more than one, that's why this choice thing could work, except we don't like it. So I guess if we say no too, but then you have the nightmare scenario Mike was talking about, and then what do you do then? You're screwed, right? So.
Deirdre Sandbox, I vote for 2. You can be a just born yesterday baby and read FIPS 203 and FIPS 204 and implement seeds. You do not necessarily do only the full expanded format for MLDSA or MLChem, so there's that. But also, many of the documents in IETF talking about MLChem and MLDSA are saying, let's do seeds. So we're already forming documented consensus and implementation consensus about we like seeds. So that exists before the hardware modules start getting implemented. And it is more efficient. It's more space efficient. It is more compute efficient to use seeds. I think we should just set ourselves up for success as opposed to being so afraid of failing. And I think we can get to a very lovely place.
And to be fair, the horror scenario isn't the world burns. The horror scenario is the hardware I'm trying to import into needs to have a full shaped import function, which is a little, I mean, I can, if I'm buying new hardware from a new vendor, I can make them implement the import that I need. So it's not.
David.
David Benjamin, echoing what everyone else said, only do the seed. So if you, in particular, if you like say you're allowed to ignore one of the options, you haven't actually solved your interop problem. Because what will happen is that the reasonable implementers will go, I don't need to implement this ridiculous full thing. I'm only going to import the seed. And now you think that everyone speaks the same format, but actually you've made 2 completely disjoint formats that like happen to share a choice thing. And so you'll think you'll be able to import it, and it can't actually import. So we should just stick with the simple thing. On the sort of more optimized representation, keep in mind that this is an interchange format, not an in-memory representation. It is totally reasonable for an MLDSA or MLChem implementation to keep the expanded matrix and various other things in memory, but that's an in-memory thing. You don't need ASN1 for that. You just need like, you know, a struct.
Yeah.
We're talking about P12.
Talking about P12 files. So it sounds like everyone likes option 2, so we'll use the seeds. So seeds is the answer. Yeah, go ahead.
Queue's empty.
We all agree. Sean and Boss are going to do 2. Next, moving on. Great. Now we've had the debate. Okay, cool. Please next.
Yeah, this is next.
This is next. Yeah, so what does it mean for composites? Woo! We do the same thing. I think there's nothing rocket science here. There's that bottom bullet that we already debated about X-wing. Anyway, next. Cool. I've already done all this. Next.
You already talked about this too.
So yeah, the thing on here that's yeah, I mean, so after we did a huge massive revamp. Last time we put up the GitHub numbers, which make me cry that we've done one GitHub issue a day since August, and I'm very tired. But so after all of that massive breaking changes, I think we're not quite, I mean, we're not ready for working group last call, right? This is all recently hacked. The second point there is we've got these 6 documents, which are all sort of interrelated. And I think there's an interesting point to be had about exactly how interrelated are these 6 things. I mean, we're having slides here that I need Sean to fix. Do we want these things to progress together? Do we think any of these is ready to progress first?
Yeah.
Russ has an opinion that's maybe different than mine, and he should state it at the microphone.
I think we need to move the CMS and certificate pure ones as fast as possible, so that you can depend on them.
Seeing no cue, discussion had.
Yeah, I was gonna say, I agree with that too. The one last thing we've been talking about the last day or two is we're probably gonna have a -04 version that again is not binary compatible because we're gonna remove the ASN1. That sounds like we're coming to consensus on that because some people in other protocols want to make use of it and they don't like the ASN1, even though it's very basic wrapping, it could be stripped. But I mean, we can remove it too. We know by the OID the sizes, so we can do that. So that's probably something we're gonna do as well, just to let you know. So that's the next steps. Any last questions now that we've taken up almost an hour? So I think we're done then.
Okay, Sean, you're up next. It is very clear to me that having spent an hour on composites, that we are not going to finish the agenda. We will keep going as using all the time we can. And whatever we don't get to, we will schedule an interim to finish.
So I'm going to try to go as fast as possible and basically ask for people to take most of this to the list. So I may see some things that are controversial that I want you to go to the list for. So again, my pink slides. Oh, and I should note that when I tried to pwn the internet with 32-bit keys and 64-bit seed keys the other day, I got those slides updated so they now say bytes. Next. All right, so CMC BIS. It's Joe and I. We're going back and forth. You want me to run the slides? I can do that. So the update. We did what we said we were going to do. Last time we had a list of PRs that we were going to merge once we made it a working group draft. We did it. Now it's an 01 version. It actually includes the changes. Thanks, Joe, for going through all that. The only thing I really want to kind of highlight here is the direct pop mechanism or the pop mechanisms in CMC because it's related to CMP and stuff. And I want to make sure that we all kind of understand and the smart people review it to make sure that it actually does what it says it's supposed to do. So, all right, cool. So a little background here. We added some direct pop stuff. There's like 4 slides later to kind of explain it. CMC's pop background. CMC only supports direct pop, right? There's indirect pop and direct pop. CMP kind of went through and did all of it. They basically just said, just do one. Like, this is how it works. Be done with it. I'm not proposing that we actually add indirect pop because I don't think we need it. So, and the fun thing is that the other background about subsequent rekeys and renewals, which I think you guys asked about last time, I was going to go off and look at it. I forgot. They just do the same thing as the original request. So you basically just start over. I guess only one request. The only thing that would be weird is if you have to like link back to the original certificate that you had. But if you're talking to the same CA, they can look that up. So it's just not that big of a deal. All right, next.
It's in your hand.
I'll get this done yet. All right, pop messages. It's an eye chart. It's in the draft already. It's in an appendix. You can see it. The way I kind of want to describe this one, the first message is it's the message from the entity to the CA, and it's like, hey man, give me a cert. So what do you got? You got signed data because it's a full PKI request. You got a content type. It's the PKI data. You include some control sequences, which are ways to do tracking of things, et cetera. So you get a transaction ID, a none, so a data return, which is, it says stuff up there, but technically it's a thing that It's a thing that points to where the key could be located. Then you have a request sequence. It's a CRMF or PKCS10. Include your name, your public key, what key usages you want for ML Chem certs. It is key encipherment. And then you say more pop stuff in there about what is key encipherment. You say it's the next message, and you sign it. But you sign it with this algorithm called no signature, and it's nothing. It's a hash. Check it. There's no security in it at all. You're just putting it on there. Why are you doing that? Because signed data requires a signature. So we're just sticking it in there. Off we go. There wasn't a somebody submitted a RADA on 5272 about this, and I think we're just going to say, since we're doing an update, hold for document update. Next. All right. So this is the message back. If I click the button, I watch a lot of Bluey with my children, so it's more like, nah, mate, do some pop. So off we go here. You got assigned data. It's what gets returned. You're going to apply a PKI response. You include some more control attributes, which is like, hey, this is the status information, your transaction ID, send back another sender nonce, some more recipient nonces, and then the encrypted pop, because there's two controls that you care about. One's called encrypted pop. The other one's called the encrypted witness pop or something like that. So what you got in there is a request. And this is the CA basically saying like, hey man, that was really cool, but try again. So what he's sending back basically is this request, and here's the pointer to the thing. And then there's a certificate template is like, hey, this is what you asked for. And then the popo that comes back is actually the challenge, right? And then you encrypt this other blob of CMS stuff, which is an envelope data using the chem RI info that just got published, right, as an RFC. So we're using the data that the format we already did. And so what do you stick in there? Well, the e-content type is this encrypted random number that you basically came up with. And then as part of the encrypted pop control that gets returned, you also get a pop alg ID, which tells you the alg you're going to use when you come back. And I picked one that's cool because it's KMAC and it's great because we're using new algorithms, and we should do that. And then the witness alg, which you're going to send there, it's also like shake 128, just because it's an example. And then you're going to actually hash the Y value. And then you're going to put it all in there. And then the CA's actually got a cert, right? So you can actually sign it and send it back. And you can also include in the certificates the CA's key that you could use to encrypt back for them. It's up to you. It's just a bunch of stuff. Yes, Mike.
Point of clarification, this is an example, right?
Yep.
KMAC is cool and new and we like it. Is it like mandatory to implement or like required or like nothing else can be here or?
Nope. So we get into that the second to last slide where I'm going to be like, nah. So there's a lot of choices, a whole lot of choices.
Hi, Jonathan Hamill, Canadian Center for Cybersecurity. I know you're trying to simplify things, but under the encrypted content info, I'd recommend you include the content encryption algorithm AES.
Yeah.
So that it's clear that encrypted value is using a symmetric scheme, because this is in a section which describes RSA or chem.
Yeah.
And so it would just help that clarification.
Yeah, fair enough. I can do that. If you'll remind me, that'd be great. All right, cool.
Send an email.
Yeah, send him an email, or you can do a pull request. That works. And the message that comes back is like, either way, it's a PR. PRs are always welcome, right? So the next message that once the CA sent the message to the entity gets it, and he's like, hey man, I'm gonna do some pop goes the weasel here. So he's gonna send back I tell you, this is what happens when you make slides after a couple glasses of wine. So you're basically sending back signed data with a bunch more transactions ID to complete, checking to make sure you're not getting pwned anywhere. You then start to include the decrypted pop back, right? So you're going to send the pop alg ID to make sure that you can do check to make sure that the value that was sent to you, they can get it back. Then the request sequence actually includes your request, and the subsequent cipher challenge response stuff is the response. And then, hey, guess what? Use the same no signature algorithm ID, and off you go. And then the response is like, hey man, here you go. So it's profit, right? It's the whole go Star Trek stuff. And so you actually get the cert back. My assertion, Joe and I went through this, I then ran it by Russ, he told me I wasn't crazy, was that people should look at this. Now, I know there was some message on the list about some people hating the no signature algorithm thingy. It's been out there. I have no idea how long or how much it's been used, but it was specified, and I was trying not to come up with new things. So I was like, great, we can do this. With the existing things that we have, and assuming that all the stuff is good, I think we're good to go. Because the other idea that I started off was like, hey, great, let's go do a signature like we do with ECDSA or Diffie-Hellman. So I asked some smart people who are cryptographers, and they were like, nice try, but no. So it's hard to basically, like, you can't use a chem key, I believe, directly to make a signature. So you're kind of stuck. So, or indirectly. So it sucks. So you got more round trips. It's not just give me a cert, here's your cert, like it used to be in the past. And that's why I think we shouldn't try to bother trying to extend like P10, because you can't do it. And then if we do that, we're just making another enrollment protocol. And like, I don't want that, because there's already like 10 of them. Right? Are you going to tell me I don't know what I'm talking about?
Nick Chakowski, NSA. Now I had a question because you plan to do this as well with RSA, because RSA is not a chem, and so
there is an
that's really
RSA.
different.
So there is an RSA example in there it's very similar, but slightly different. But I think for the RSA chem, I think it's supposed to still work.
Yeah, I mean, yeah, I was just wondering if it's just the non-chem version of RSA.
Oh, no. So there's another example that's already in there for a non-chem version for RSA that explains how to do this.
Okay.
But I think that one assumes that you've got a signature certificate, because they cheat, right? It's like, oh, it's really easy until you actually like come into reality, and not everybody has a signature cert.
Okay. All right. Thank you.
Cool. No worries. And then the other things I got to do are
the to-do list.
Yeah, the other thing is a to-do list. This is what I currently have in the algorithm section. Right, this kind of stuff hurts my brain because it was from eons ago. Right, I got to change it, and I don't want to pick these because that seems like a bad idea. So I found this CMP document, which is the algorithm requirements, and I'm just going to copy those ones and be done with it, so that nobody can argue with me about it's the wrong choice. The only thing is, neither one of those include any of these new algorithms. So what I'm going to do is I'm going to copy what's in the CMP document, somehow figure out how to format it the same way, and call it done. And until such time as we get done with all these other ones, then we'll add it. We could add it before this is done because we might get done earlier, but blah, blah, blah. So I just want to let you know.
Thank you, Hendrik, a beer.
Yeah, I do actually, because I was like, I don't want to pick any of this stuff because some of these are crap, right? So, I mean, at the end of the day, it is what it is. And I did offer to give Hannes some text, and I looked at his drafts, and basically it's pretty straightforward. If you want to do this attestation freshness stuff and the CSR attestation stuff, basically all you need is define a CMC control. He already defines a PKCS10 attribute. I can do the same thing. I will use the same syntax, even the same OID. It's going to slip right in there. The fun thing about the attestation freshness is the first message, if you remember that he had, is it's like this request for like, hey, give me a nonce. CMC doesn't really do that. It's like, give me a cert. It's not just give me a nonce. So I have to figure out some way to like basically kick off this now mate, give me a nonce thing, or, here's your nonce response using CMC. I know
doesn't it work just like your I beat your
well, right,
challenge?
but you have to give it something, and it's like that's a dumb request. You need to give me this, but it seems weird to do multiple round trips to get a nonce. So it is what it is, unfortunately, in the protocol. So I think I just might have to eat that. Again, I don't think there's a whole ton of people that are eating this dog food, but I think at the end of the day, we should try to get feature parity. And having looked at it, it doesn't look all that difficult to add. So I'll get on that. And that's it. And again, please review the stuff in the appendix to make sure that it actually makes sense, so that I'm not selling you guys a load of bull.
Hi, Sean. It's John Gray.
Yeah.
I was just going to say you mentioned you're going to copy stuff from the CMP, which is great.
I mean, like
but we obviously need to we'll probably need to do another CMP update document so that you can copy latest stuff. Anyway, we should collaborate when we update that or add updates at the same time. We can discuss stuff.
My assumption is there'll be a class of things, and one will be if you want to do PQ algorithms that are elliptic curve or that are MLDSA, you do this. If you want to do ML Chem, it's this. I'd have no idea what those values ought to be.
Yeah, because there will need to be like a CMP update doc that adds MLDSA because we added chem support to CMP 3 that's being worked on, but we haven't done that. And if you're going to copy, we need to be in sync.
Yeah. So it's all fun. Yes. So all the things. It'll be a huge matrix.
And shot.
I'll get really good at that in Markdown.
Sama to you, Dresden. Can you elaborate a little bit more about the CSR attestation that you have, the proposal that you're mentioning CMC?
Well, no, so this is a generic, I read the two drafts and my attitude is like, all right, I said I'd do some input. I'm not going to put it in my draft. I'm going to put PRs on those two drafts. Yeah. And so the CSR attestation draft
Yeah,
Basically, it's
CSR
about defining an
attestation,
attribute.
I know, but can you elaborate on the CMC control? What's
So it's a control is basically like, because there's 20 ways to do this, right? There's a PKCSN attribute that you can include in the CSR.
Mhm.
Instead, what we do is we put a CMC control in the CMC control section.
In the CMC PKI body.
Yeah. So if you go to the requests, message one, these things are controls. But what we can do is it could be an attribute. So you just have to, like, because of the ASN1 style syntax, you got to make it a control and just use the syntax. It's the same as the attribute.
Okay.
That's all I'm doing. So like, I'm basically just copying and putting a different wrap around and calling it a day. I'm not trying to invent anything new.
Right, thanks.
Yeah. And the nice thing about CMC is it does support PKCS10, so it can just use the stuff that's already defined there. It's a bit of a circular reference, but it does work. All right, cool. Michael.
Just about the freshness. So I think actually the good news for you is that you have multiple round trips, period, right? Which means there is no introduction of any other stuff to get the freshness. Whereas as Mike and others were dealing with the CSR attestation, there are basically work models that effectively amount to, I go get a CSR from something, I extract it through, QR code or line printer or something. And there's no actually ever any kind of back again, because the certificate being a public content doesn't actually need to go back into the device in some ways. And so they never actually had that backflow, period, right? At least in their brains, they didn't have the concept that they do this. And this protocol requires at least, I think if I understood, at least 2 round trips.
For if you're going to do.
No, 1 round trip is the minimum.
Okay, it's off 4 messages.
Well,
that's because of the.
That's
okay. Anyway, it doesn't matter. The point is that for that if I understood it right, you're getting that nonce in that first round trip anyway, right?
When you can add one, so I could look at that. Yeah.
Okay. Well, okay. I thought I saw it anyway. Yeah. The point is that as long as you've got at least 1 clear round trip, adding 2 doesn't require more wires, right? In some sense, right? Okay. So I think that's all. Everything looked good to me. Just yeah, whatever.
All right. Okay. The devil's always in the details.
To do POP, you need 2 round trips. You don't always need POP with CMC.
Mike Ounsworth, statement of fact, rats is bad for your health. I suggest if you want to get this published, don't lump attestation into it.
Oh, I'm not. My point was to put a PR on those other 2 drafts, 1 on each thing is to add it there.
Yeah, awesome. So having just come from Acme, where I presented Peter's slides on a mode where the Acme server, you can say, hey, Acme server, I want a cert for this CSR. And Acme server can say, hold on, to issue that cert, I need proof that you're on a patched Windows and running corporate antivirus.
Right.
You might need a control here where the CA can say, hold on, you need to provide me the following list of proofs. Good luck. I suggest you not try and do this in the same BIS document.
Oh, no, absolutely agree. It will not get done in a timely fashion, at least. All right, cool. Thanks.
Okay, the next thing on the agenda is 5979 BIS. Is there any update? We did not get slides for that.
Sorry, you mean 9579?
Yes.
Yeah. I just get so Alicia Cario, Red Hat. We just got I got a note from IANA that we probably should update the IANA recommendations to update it to the new RFC, and that's basically it, I think. So I will just need to ask for help with that, because I have a pull request, but I'm not sure if the phrasing is correct.
Okay, that's straightforward. Thank you. Yeah. There we go.
Okay, gotta go fast. Oh, This is not the one I was expecting, but I can do this one. I was expecting the MLDSA one, but let's do
Oh.
ML Chem. Oh, that's fine. They're
You're
both-
no, but I'm wrong. I
Okay.
grabbed the wrong one.
Okay.
Yeah, I have the order backwards.
MLDSA in CMS. This is what our matrix looked like before of drafts. This is what it looks like now. Yay. What's in a draft? We stole a lot of text from the lithium certificates and CMS Sphinx Plus. No hash MLDSA. Everyone should be happy about that. All of the MLDSAs, ASN1. We got feedback already from the call for adoption. Thank you very much. Want to bump the digest algorithms from recommended to required. Russ already made those changes to CMS Sphinx Plus. I am going to copy those. When we're talking about digest algorithm, this is just for the digest that's used in the signed attributes. There was a suggestion to move from Shake to SHA-2 as the same reasoning for within KDF. I don't know if people agree with that or not. The reasoning is, well, because we might have SHA-2 at the CMS level, we might not have Shake at the CMS level. So yeah. Oh, well, yeah, so that's what the text that Russ updated there makes it clear. So basically, the digest algorithm will specify one digest algorithm as mandatory to implement just for compatibility and add explicit text saying that you can also implement whatever else you want. SHA-2 would be the lowest common denominator, yes. No disagreement there, so we'll keep it that. Something to do with EUF, CMA, and CMS, maybe we'll talk about that later if there's time.
At an interim, I'm guessing.
Probably, yes. This was self-feedback about introducing a non-digest for the non-signed attributes. This was discussed 7 years ago, so I withdraw my feedback. That's it.
Questions? So we need to get this to last call real soon, right?
Yeah, there's no dependencies, so that's super quick.
All right, so when do you think you'll make these updates?
Next week.
Great, awesome. Thank you. And next is Kyber, the ones I had
Kyber.
the first time.
Yes.
All right. Those.
Yes, MLChem in CMS. We had version 5, which aligns with FIPS 203, does examples, and sets the KDF to HKDF with SHA-256. This might be a problem based on what Mike was talking about in his last presentation. Only HKDF with SHA-256. The reasoning is people want it. FIPS 203 says that any of the SP856C KDFs are allowed. SP 856C 5.1, last paragraph says, RFC 5869 specifies a version, blah, blah, blah. But if NIST says it's not actually allowed, I don't know why this paragraph is in there. So, clarification. And then NIST, or a representative from NIST said on the PQC forum that they intend to allow KDFs from, they're basically making it explicit what, in a separate document, what the FIPS 203 says. But again, if 56C only allows the HKDF extract and not the HKDF expand, despite what the implementation of the second, or the implication of the second line is, then I don't know what we're going to do. Go back to KMAC? We can't. So for composite chems, it's fine because they can use extract and they don't need any more keys than that, but we need the expand because it has to fit into chem recipient info, which takes a length. So feedback. It would be nice to keep it at HKDF with SHA-2 because we've changed it 3 or 4 times already. And if we change it once more, it's going to be KMAC and that's it. So, especially from NIST feedback. Or Mike.
Quinn Dang from NIST. the options we specify and we allowed, and that's all we say. We don't have issues with either SHA-2 or SHA-3 based KDFs. So it's up to the group to pick whatever the group thinks is the best.
But I thought earlier you said only the HKDF extract was allowed by NIST and not the HKDF expand.
What I said was the extract step is compliance with one of the KDFs in 56C.
Yes.
Yep. So right now it looks like we either do that or you do the KMAC or you do a SHA-3 KDFs or SHA-2 KDFs in 56C. Then you will be fine here. So we have a lot of options here. It's just the group to pick the one we think are the best for the group to use.
We like this one.
Yes. It still feels like it's not NIST compliant because we have to use the HKDF expand.
Yes.
But if we like it.
Maybe you could give me a little more time when I go back, talk to my team, and if we had a decision about it, and then I would share with you right away. But I cannot promise the timing. But the best I can do is I do the fast thing I possibly could to push my team to make decision on it.
Okay.
Thank you. Yes.
Yeah, that's what I'm hearing.
Mike Ellsworth, a couple thoughts. So I respect and love that NIST is considering this. I don't think we want to wait. Like if the answer is it's allowed today, then awesome. If the answer is anything else, then do we have to wait for them to publish something? Also, sort of, this is exactly what I had hopefully delegated to John Matson to start a mail list about. So I suggest this is too complicated to do at the mic, and maybe we should do this on the list.
Okay. Last point, 256 is enough for a KDF. Next, fix the private key examples because I was still using the expanded format and not the seed format. So I got to change that. Depend on Kyber certificates. I had indirectly asked for working group last call, assuming that we still had to do these changes. I'm not asking for that anymore. I'll make these changes and then ask for working group last call. The end.
Any further questions? Okay.
CMS Sphinx Plus.
Oh, CMS Sphinx Plus, no slides. We just posted a draft like last week, and then Daniel found some mistakes that I fixed them on Monday. So I believe it is now ready for the ISG, waiting for Tim to do the Shepherd write-up. We already did composite chems, which is the next one. So we have the special topic. The question is, with 10 minutes, do you think it's worth beginning?
Falco's going to present the attack, so it depends if Falco can do that quickly.
So that part's certainly worth doing. Where are they slides?
He said it'll happen.
Yeah, we'll have to do it.
Yeah, there will be an interim.
I posted them to Datacracker yesterday and they were approved. Should be called EUF, CMA, and CMS.
They're not in Medico. We're of course time constrained.
Yes.
Will it take 10 minutes?
It will.
Yes.
Yes, that's the solution. Might not have time to get that, but if Falco can at least present the attack and then people have time to read his paper before the interim.
Slides, Falco?
Or we can skip it and do the entire presentation in the interim.
Okay.
Falco, are you able to very quickly go over the attack without any slides?
Mike Elmsworth,
I mean,
especially with Deirdre and Sophie here, if you could at least like just show the core idea of the thing and why context is you think useful for something, I think that would be helpful to get
Yes.
brains turning.
Maybe I can share remotely. Is this possible?
Sure.
How do I do it? Ask slides or ask share screen?
Yep.
So the lesson is don't upload the slides the day before. It was yesterday.
We're not seeing them. Did you share them?
Doesn't seem to work. It says I'm sharing the screen, but
We're not seeing them.
mm,
Ask to share screen. Yes.
I can just
No.
hold up my laptop here if you want.
No, it's showing me selection of uploaded slides only.
Yes. So that's what we can't find. I don't get it. Find the slides.
I didn't.
Should be EUF CMA and CMS. Or slides 121 lamps, EUF CMA and CMS.
If we can't get the tech issue
I
to work,
think-
can we at least get you to talk to you offline? That would make me happy.
I think it should work. One moment. Oh, okay.
Yay!
All right.
Only took 4 minutes.
Okay, so
You just go ahead.
okay. So then ask me to give a brief summary of the paper that I wrote, which is just a very trivial write-up or a write-up of a very trivial observation, which was surely known to some, but maybe not to everyone. So this was the reason why I wrote it. So as part of any CMS signature, there is these signed attributes, which is potentially in the signed part of the signed structure. And it's a sequence of attributes, and one of them is a message digest attribute, which contains the hash of the message. So you don't sign the hash of the message directly, but if you sign with signed attributes, which you can, or you can do it otherwise. You can simply sign the message, but if you use the signed attributes, you sign the signed attributes, which is just the there encoded sequence of these signed attributes, and we indicate it with M because it is specific for the message M due to the hash that's contained in them. So now the important fact is that it's part of the signer info, but it's optional. Now, how does the CMS signing work? So you have the message, and then you either compute the hash of the message
as the digest, which is the case if signed attributes are not used, or if they are used, you sign the signed attributes. Now, the problem is that, let's take the case that the signed attributes are absent. The attacker could let the signer sign a message which has the form of the signed attributes for a message of his choice, M prime. The signer thinks he signs a message that looks like this, which only contains the hash of M prime at some point in it. But actually, now the attacker can just prepare the whole sign structure and say that the signer signed M prime, because now it looks like he had taken this path. Of course, we also have the opposite. So, in one moment, and in this case, so there can be forged signatures for arbitrary attacker chosen messages, but the signed message is of a specific format. In the other variant, of course, it's the other way around. The signer actually signs with signed attributes, but at this any message, but of course, then also there could be a message, there will be a message M prime, which is just the signed attributes. So here also signed a message which looks like the signed attributes if the attacker makes some trivial transformation to the signed structure. There are some unaffected protocols, which is the case if signed attributes are mandatory, which is kind of the modern way of using CMS, or when messages are encrypted after being signed. But apart from that, if that is not the case, in a system which allows the absence of signed attributes, then you could have, if you have trivial protocols which are maybe not using any structured data, but maybe directly sign a firmware update. So you could just have some kind of garbage signature valid for some garbage firmware. You could have protocols with dense message space where by accident the strange formats of the signed attributes coincide with a valid message in a machine-to-machine protocol, or you're assigning unstructured data, just some tokens. And especially we have to consider that there are systems with permissive parsers, maybe they stop after the message they wanted to pass, and maybe there's some trailing bytes they ignore or something like this. Okay, then I hand over to Daniel.
Sophie has her hand raised. I see Deirdre was nodding along the entire time, so this is promising.
Yeah, my main, can you go to the CMS sign slide? Yeah, or the one before. Yeah, this one works great. My main concern with the context is not that the context is bad, because this is clearly something where you needed the context. My main concern is that they would just have the context as an attribute to this procedure and return sign KSD context. Like basically what I'm saying with the context thing is that I'm not certain that it prevents this type of vulnerability, because people will pass this context through. And if they don't add the context in this if statement, then you have not gained anything. I am not certain that that is the case or not. I really, like, I think Bas made a very, very good point, and that has kind of changed my opinion there, that like having the context available is a different thing from like using the context in a specific place. And so I think I'm kind of aligning myself more with Bas now, that like context as an option good, as a cure-all thing, no, because you can have this vulnerability just as well with context, unfortunately, because people do weird stuff.
So you're saying the implementation would just not set the context?
Yeah, so what I would assume would happen is that either the context would be always empty, or that CMS sign would have another argument that is called context and then return sign context. Like I've seen enough of these kind of things to know that developers are very creative in finding ways to make things bad.
So, I mean, very, I don't even know which slide it is. Very quickly, the solution, the generic solution would be to add a new attribute to CMS, which is the signing attribute, signing context, and that gets sent with the CMS blob. Can you find it, Falco? It gets sent with the CMS blob. So the signer says, this is the context that I've used. We would set a specific allowed context. So for when we're signing with signed attributes, the string would include signed attributes. It could be expanded for other stuff for application context, etc. Scott.
Yes, Scott Fleur, Cisco Systems. I don't want to underestimate the creativity of implementers. However, if they actually do something which actually breaks interoperability, that is obvious. And I believe getting the context wrong in this case would break interoperability.
Yes.
Okay, we are out of time.
Thank
So
you.
we have an agenda for an interim. We will doodle on the list for when that interim will take place. All right. Thank you all. An hour. It had to happen
It
though.
was good. I was sitting there and I was like, is this going too long? No, this is actually.
Yes, it's going too long, but we need it.
Yes, exactly.